So this is the 7th chapter from the AICE1 book about applications of differentiation, and these are the objectives that we're going to cover within the whole chapter. Now the first question actually goes back to the type of thing you would have done in Algebra 2. So x squared plus 6x minus 3. If we were to complete the square on this, for example, so half of 6 is 3, 3 squared is 9, but I actually want negative 3. I can take away 12, and then the vertex for this, remember, do the opposite of the one inside the parentheses. So the vertex for this will be negative 3, negative 12. So if I draw a little sketch, something like this, positive x squared here certainly tells you it's going to be a U-shaped graph. And I've also got a y-intercept of negative 3 here, so probably not the most accurately drawn graph. But if I was to ask where this is increasing, often you were given the graph, and you can see it's increasing, like here. Or alternatively, it's decreasing on this part here. Now the actual definition is increasing is positive slope, decreasing is negative slope. So importantly for you, slope is dy by dx. So increasing, we're going to say that the slope is greater than or equal to 0. Or if it's decreasing, we're going to say that the slope is less than or equal to 0. So what we're going to have to do for all these questions then is actually differentiate. We're going to pretend that that graph's not there for a second. So to differentiate f dash of x, differential of x squared is 2x, differential of 6x is 6, and differential of negative 3 is 0. Now if I do increasing, that means it's greater than or equal to 0. So if I solve this, bring the 6 to the other side, then I divide by 2. Careful on this stage not to flip the inequality here. Although we've got a negative number here, we're only dividing by 2. So as 2 is positive, we're going to leave this alone. Now actually the vertex for this I actually said was negative 3, negative 12. So we can certainly see all the values to the right of negative 3. So x would be greater than or equal to negative 3. Similarly for decreasing, I would just set this less than or equal to. So actually the answer will be x is less than or equal to negative 3. Now we can make this slightly more complicated, but we're going to use the same idea. We're going to look at the differential, bring the power to the front, multiply it, and then decrease the power by 1. Same thing, if it's increasing, when is it greater than or equal to 0? And then we go back to our chapter on quadratic inequalities. So we're going to solve that quadratic inequality, and then we're going to try and graph this thing as well. So I'd have intercepts for this at 0, also 4, positive 4, 2, 3, 4. And this is a positive x squared. So my graph would go like this. Now this is not the graph of this function, this is x cubed. This is actually the graph of the slope function. So everything above the axis is positive slope, anything below the axis is negative slope. Even though this looks like positive slope here, you have to look at the value on the y-axis here. So we're looking strictly at when is this graph greater than 0. So actually we're looking here, and we're looking here. So in other words, everything to the left of 0, so x is less than 0, and anything to the right are positive 4. So that would be our answer for increasing. Decreasing is when it's below the axis, so we're looking between these two values. So if it was decreasing, I would go with 0, less than or equal to x, less than or equal to 4, to show that x is between 0 and 4. Now the last question I've already got prepared a little bit, so you might want to try this and then pause the video and then continue to see if you can agree with this. So differentiated, took x as a factor, factored for a second time, and then I use this to draw my graph. So 0, negative 2, negative 4 my intercepts, positive x cubed here, so it looks like this. Increasing means we're looking above the graph, so between these two numbers here, and then anything to the right of 0. And so if I was to write that in, then I could say between negative 4 and negative 2, and then anything to the right of 0, so x is greater than 0. Similarly, if I was asked decreasing, I could say x is less than negative 4, or x is between negative 2 and 0. So really this links in very well with your work on quadratic inequalities, drawing graphs, and also that differentiation that you were doing in chapter 6 as well.